Here's an example of using the method of completing the square to solve an equation that has something other than a 1 as a coefficient of the leading term. So when we complete the square, we'd like to have just a 1 as a coefficient of the x squared. So there are a number of ways of doing this. Because we have an equation here, what I'm going to do is I'm going to divide both sides by 2. In other words, divide every single term on both sides by 2 to get rid of that 2 and leave us with just x squared. So I have x squared minus 3/2, because I'm dividing this term by 2, minus 1, because again, I'm dividing this term by 2, equals 0. Then what I'm going to do in this case, and again, there are a couple of different ways to do it, a few different ways to do everything. I'm going to first move this -1 over to the other side. I'm going to add 1 to both sides. So I just have my x's here. So I have x squared minus 3/2 x equals 1 over here. So I just moved that 1 over. So what the object of this, of completing the square here, is to add a number to these two terms that will make this a perfect square trinomial. And when we have a perfect square trinomial, it factors easily into the form that we want. So this is the method of doing that. The first thing you do is you identify the coefficient of the x term, which in this case is -3/2. And I'm just going to put that over on the side here, -3/2. Okay. And this is what you do with every problem of this type. After identifying that coefficient of the x term, you divide it by 2, or you can say you can multiply it by 1/2. That's the same thing. So that's the first thing I do, is divide and multiply by 1/2. And in this case, we end up having -3/4. Okay. And I'm gonna remember that. That number is gonna come up in a minute. So I'm just gonna put a little arrow there. Okay. And then the next thing we're going to do is we square that result. We take this -3/4 and we square it. And in this case, we get 9/16. 9/16 is the number that we want to add here. And so I'm going to do just that. I'm going to add 9/16 to this side. Now, of course, we just can't add 9/16 just because we want to. If I add 9/16 to one side of the equation, I have to add it to the other. Another way of looking at that is if I add 9/16, I'm also subtracting 9/16 from this side. In any case, we have to keep this balanced. But the addition of this number, that we figured out by taking that middle coefficient, the coefficient of the x term, dividing it by 2 or multiplying by 1/2, and squaring it, gives us a perfect square trinomial here. And the perfect square trinomial factors down, this particular one factors down to x minus, the minus is because this sign is negative, and then half of this coefficient, which is this number here that I put a little red arrow. That's always going to be half of your middle coefficient because you divide by 2 or multiply by 1/2. So 3/4 is what we put here. It's going to be x minus half of this number, quantity squared. And over here, I'm just going to add these together. This is 16/16 plus 9/16 equals 25/16. And we've completed the square. I'm going to continue with this and solve the equation. So since we have it in this form, I am going to say that this means that if this x minus 3/4 squares equals this number over here, then x minus 3/4, it means two things. It means x minus 3/4 equals positive the square root of this number here, and negative. So I'm going to say plus or minus. It means it's shorthand for two separate equations. This equals plus the square root and minus the square root. And we just have to move on and simplify. And the next thing I would do here is simplify this. Plus or minus the square root of 25/16, of course, is plus or minus 5/4. And I'm going to add 3/4 to both sides. So I'll isolate the x. And x equals 3/4 plus or minus 5/4. And again, keep in mind that that plus or minus is shorthand for two separate equations that we're actually just kind of solving at both at one time. And we have x equals, well, 3/4 plus 5/4 is 8/4, which is 2. And another solution is 3/4 minus 5/4, which would be negative 2/4 or negative 1/2. And that's our solution set, negative 1/2 and 2.